Geometry means land measure and really is the mathematics of space. Now, to start with talking about geometry, we have to have the basic measurement called an angle, and that's a measurement of the openness between two sides that meet at a point called a vertex, which you can see right here. We have these two sides and they meet at this point called the vertex, this point right here. And you can see that the angle, we can call this, typically in mathematics, we use Greek letters like alpha or beta. This is the measure of the openness between these two sides. And we're starting from some side, that's why it's called the initial side, and ending at some side called the terminal side. So this is the angle that we're talking about, how open these two sides are. Now, angles are going to be measured in degrees. That's what we're going to use here. A better unit is called radians, but radians are more cumbersome for what we're going to be doing. Radians are more preferred for a lot of specific engineering or physics applications. They're just a better unit, but we don't need to worry about them here. So degrees are measured between 0 and 360. 0 is 360. If this was my initial side, full circle would be 360 degrees, but that's the same thing as just going at 0. So you can have degrees that are less than 0 and degrees that are more than 360, but you end up just circling around and around. If you have 0 to 360, not including 360, then you have all of the angles that you can have. Of course, a protractor is an angle ruler. You can use that. We're not going to be worrying about that here. But you can use a protractor to measure angles physically. There are four main types of angles, and for larger than 180 degrees, I'll talk about that in a second, but the first angle we have here is an angle that's less than 90 degrees. 90 degrees is a right angle, and it's also called a square angle because it makes this square here. An acute angle is an angle that's less than 90 degrees. You can see that 90 degrees would be a straight up like this. That would create a square angle there. And an acute angle is less than that. It's somewhere anywhere in this range. These are all acute angles. So a right angle of what, like I said, was 90 degrees. It creates this square that it's always shown with this box here to show that you have a 90 degree angle. An obtuse angle is going to be an angle that's greater than 90 degrees, but less than 180 degrees. So 180 degrees, as you can see here from this one, is called a straight angle. That's just going all the way across. So this is 180 degrees. The obtuse angle is going to be between the 90 degree angle, which is going to be straight up like this, and 180 degrees. So anywhere in this range here, these are all obtuse angles. And like I said, a straight angle is just the angle on a straight line. I could draw any straight line like this, and I could create a point on there. And the angle across that is going to be 180 degrees. That's what a straight angle is. It's called straight because it's a straight line. If we have an angle that's bigger than 180 degrees, like if we have this, right, this would be the straight angle here, and this angle is bigger than that, that's what's shown here in red. Really what we can do is just measure it by this angle here. And this would be an obtuse angle here. Now, we can sketch angles, and we're also going to label these things. First off, this first one here, this is an acute angle because it is less than 90 degrees. Okay, an acute angle, it's 30. Well, if this is 90, right, this would be the straight angle there, or the square angle. Then 30 is going to be 1/3 of this. So if I were to just evenly cut this into thirds, something like this, then this here would be 30 degrees. I'm just estimating it here. Okay, 180 degrees. This is a straight angle. And to graph this, I can graph this in any fashion I want. I'll just draw a straight vertical line, and then that is the straight angle there. Okay, 90 degrees is a right angle. And this I can just draw, as long as I create this kind of box looking shape and then I label it like that, that's a 90-degree angle. You can, of course, draw it in any fashion. You can rotate it around like this. You know, you could also have it like this. All of these are right angles. Now 135, this is going to be an obtuse angle. It is greater than 90 degrees, but it is less than 180 degrees. So we have an obtuse angle here, and what we need to do is graph this. Now, but because it's between 90 and 180, 135 is actually exactly halfway between 90 and 180. If you were to take this, right, 180 minus 90 gives you 90. Then you divide it by 2. So we're going to take 90 divided by 2. We get 45. 45 plus 90 is 135. And then 135 plus 45 is 180. So it's exactly halfway between those two. I'm going to draw a straight angle here. And then I'm going to make a reference 90-degree angle. So this is the full straight angle here like this, and then this, of course, is the 90-degree angle. What we want, however, is 135, and this is going to be halfway between the 90-degree angle, which is the vertical here, and the 180-degree angle, which is this horizontal line going that way. So what I'm going to do is I'm going to just cut this directly in half, something like this. And this is my 135-degree angle. Okay, we can ask some questions about angles and use information given to solve problems. So if I have an angle like this angle here is 127 degrees. And I know that this angle here is 78 degrees. That's what this one is right here. Then what is this angle here? Well, if the full angle is 127, then that means that we could do something like this. X plus 78 equals 127. Then to solve this, all we have to do is just subtract 78 from both sides. And that's going to give us, let's see, 50, so 49. Yep, we have 49 degrees there. This is going to be 49 degrees. Okay, this angle here, we have a 90-degree angle shown by this square here. And then we know that this is 41 degrees. So what is x? So x is just going to be this angle here. But once again, we know that x plus 41 equals 90. Very similar to this one, right? We had x plus 78. This angle plus this angle equaled the full angle. Well, this angle, 41 degrees, plus this angle, x degrees, equals the full 90-degree angle here. So once again, all we have to do is just subtract the 41. And I get x equal to 49 again in this case. Now what's interesting about this one is that because these two angles add up to 90 degrees, these are called complementary angles. Any two angles add up to 49. So it could be 10 and 80. It could be 15 and 75, 60 and 30. These are all complementary angles because they add up to 90 degrees. Now, if I have two lines that cross each other, these are called intersecting lines because they intersect. What are the measures of the rest of the angles? Label them as x, y, and z. So first off, these are straight lines, which means I know that this angle here is a straight angle. It has to equal 180 degrees. So I know that x plus 37 equals 180 degrees. That means I can just subtract 37 here. And I get 180 minus 37, 143. So x is 143 degrees. I'll just replace that with 143. Now, I also know this is a straight angle here as well because this is a line, this is a straight line here, and that means that this has to be a straight angle. So that means that y plus 143 equals 180 degrees. But we already know that this is going to be 37. 37 plus 143 equals 180 degrees. So y must be equal to 37. And by the same kind of logic, right, this is a straight angle here. We also have this is being a straight angle here. Doesn't really matter. Z plus 37 equals 180 degrees. That's the exact same thing I have here. So Z must equal 143. And this is actually an interesting problem. These are called vertical angles. Opposite angles like this are going to be equal to each other. 143 here and 37 here. Two angles that add to 180 degrees are called supplementary. So complementary is a 90 degrees adding up, and supplementary is 180 degrees when you add them up. So that was going to be x and 37, x and y and z, or z and 37. Those are all supplementary pairs.